Hello, boys and girls, and welcome to another episode of your favorite algorithm channel. My name is Ryan Powers, and today I'm going to be taking you through LeetCode 48, Rotate Image. So this is going to be a fun problem. Depending on where your mind goes when you start this, it could be extremely frustrating or really easy. I don't know which way it's going to go for you, but I definitely recommend that you try it yourself first. But let's introduce the problem here real quick. Okay. So you're given an n by n 2D matrix representing an image. So that's kind of what this square is here. And we need to rotate the image clockwise by 90 degrees. So you have to rotate the image in place, which means we can't do a map and return a new 2D matrix. We need to do this in place. We can't use any extra space. Okay. So you have to rotate the image in place, which means you have to modify the input, the 2D matrix directly. Do not allocate another 2D matrix and do the rotation. They really don't want us to do that. So we're not going to do that. Okay, awesome. So let's just take a look at a couple examples here. So you can see here, we have this is representing an image, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and if we rotated this clockwise, you can see kind of like where these numbers are ending up, right? So this one is moving from here to this other corner. The 3 is moving here down to this bottom right corner. The 9 is moving here down to this bottom left corner, and then the 1, and then the 7, right? So the 7 was on this bottom left corner, and now it's in the top left corner. And then you can see that these numbers are all kind of rotating around. It's kind of just turning. You can just imagine that if you just took the whole matrix and you just rotated it 90 degrees. That's what we're trying to do. So this 5 here in the middle stays in the middle, right? But everything around it gets rotated clockwise. And I think it's a little bit better to look at an example like this, which is a 4x4 2D matrix, because there's actually 2 levels of rotation happening. But you can see there's no like middle value like there is on this one up here, right? So these four values in the middle do get rotated if we look at this picture here. And then actually, I think maybe even working with an example that's one index larger would actually be a little bit more helpful, because you would see kind of maybe three layers of rotation happening. But that's kind of the gist of the problem. It's programmatically kind of shifting things around, which if you really enjoy doing that, then you're going to love this problem. It can be kind of challenging to come up with some sound, concise, clear logic for making this rotation happen, but it's totally doable. And I challenge you to try to do this actually in under 40 minutes. I think is a really good challenge, because the idea of it isn't too challenging, right? It's more about the implementation. This is more about the implementation of like, how do I rotate this thing and get my logic just right. So that's the challenge for today. And as always, please try it first. And if you get stuck, or you just want to see how I solved it, then check out the video. Otherwise, if you're ready to get started, come with me to the whiteboard. So on the screen here, you'll see a 2D matrix. So it's numbers 1 through 36, and so it's a little bit bigger matrix. It's 36 spaces, but I wanted to show like a couple rotations of how this thing is actually working. And how to actually think about this structure in a way that's simple to kind of reason about. And that's why I wanted to challenge you to do this problem in under 40 minutes, because I don't think it's too difficult to actually, on a piece of paper, move these things around. You can kind of come up with an idea of how these things should move. The challenging part is actually implementing all of this movement, right? And coming up with kind of a clean, simple approach to actually implementing this rotate image function. So that's what I want to do. I wanted to challenge you to do it in 40 minutes to see if you can just get your thoughts into code in a reasonable amount of time. So anyways, there are many different ways to solve this problem. The way that I'm going to do it is not it's not the only way to solve it. It's the way that I thought about this problem. So I'm just going to share with you kind of my strategy. It's not the only strategy, but I'll share with you kind of how I think about this problem. So I think one of the big kind of concepts about this rotating image thing is when we think about iterating through an array, we always think about iterating through each index, right? We think about it as kind of like a linear thing, right? But I think the best way to think about this problem is in rings, right? So we're iterating through the rings, and at each phase we're going in deeper, right? And then we go through this next ring, and then we go through this final ring, right? So that's kind of the way to think about it, right? We're not iterating through lines of the matrix, right? We're iterating through the rings, the edges, and we're rotating each one as we go. So how would this look? Well, so what we want to do is we want to grab these kind of these 4 spots, and we want to just shift them, right? So we're going to shift them, and what we're going to do to actually make that happen is use this first index as kind of like a pivot point, right? So we would switch the 1 and the 6, and then we would then use that same index to switch these two indices, and then at the very end, once we swap these two, everything will kind of fall into place. So that's kind of the way that I think about it. We'll use this kind of starting index, or this first top left corner. We'll use that as kind of the swapping index. And then that way we'll be able to kind of just move our numbers back and forth in this kind of rotating fashion, and our numbers will kind of end up in the right place, right? So that's kind of the first way that I think about it. And how are we going to move around? So then we'll just kind of move around, the outside like so, right? But I wanted to point out that the most important index is this first one right here, right? This is the most important index because this is the swapping index. And then as we move through, our swapping index is always going to be on this first row, right? And we're going to be swapping with all the other rows in this index. So let's kind of go through how it looks just to give you a better idea of my thought process. So we'll kind of start over here, cleaning this up. And we're going to start with these first 2 indices, right? And we're going to swap these 2. So we'll swap these 2. And now 1 is in its place. So if it's blue, we're going to say that it's done. We don't need to move it again. And if it's red, well, that means that we need to keep swapping it, right? So now our 6 is in this first place, and we're going to swap it with 36. Okay, great. So now 6 is where it needs to be, and 36 is now in the swapping index. And now we'll swap 31 and 36. Okay, so now these 4 have been swapped. And we're just going to kind of work our way around the ring like this, right? Swapping these index and keeping that first part of the array as the swapping index. So we'll go through again, swapping out all the numbers, and just working our way kind of around the circle like this. Okay. So now we've got to swap 4 and 24, and now we have 24. We're swapping 24 with 33. And now we're swapping 33 with 13. Okay, now those numbers are where they're supposed to be. And then we swap 5 with 30, swap 30 with 32, and then swap 32 with 7. Okay, so now we have successfully rotated this entire outer ring, right? And now we need to move into the next ring, right? We need to squeeze in from both sides and from the top, right? Redefining our iteration space, right? So, which is going to be this next ring. So we start swapping 8 and 11, and then we swap 11 with 29, swapping 29 with 26. And then those numbers are where they're supposed to be. So then we swap 9 with 17, swap 17 with 28, swap 28 with 20, and now those numbers are where they need to be. And we move on to the next index. Swapping 10 with 23, swapping 23 with 27, then swapping 27 with 14. Okay, so now we finished 2 rings. And now all we have is this inner ring where we just swap basically these 4 numbers, right? So 16 with 22, and then 22 with 21. So it's really just about how do I define this kind of ring, right? Like how do I define my iteration through this ring? And that's going to be it's conceptually, I think, easier to think about than maybe to code. But I want to point out that we have successfully rotated this matrix. If we go through and we look at these, they're in order, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So we've basically rotated this whole thing clockwise one time, right? And so what's the time complexity of this problem? Well, it's a big O of n, right? And n is equal to the size of the matrix. Okay, so basically we have to go through the entire matrix one time, touching every single index, right? We have to swap every index. So it's a big O of n in terms of the size of the matrix, or I guess you could say it's a big O of I don't know, n plus m, but really like the dimensions are the same, right? If we treat all of these inputs like each one is an item within the matrix, then we can just say it's a big O of n in terms of the matrix. But I think that the main takeaways here are just thinking about it in terms of the rings, right? Like I'm iterating through a ring at a time until I reach the center. And once I reach the center, I'm done, right? And we're squeezing in from both sides. At every time we complete a ring, we're smashing our search space down one level, right, until we get down into the middle. So that to me is kind of the simplest way to think about this problem. It's maybe a little bit easier to think about than it is to implement, but if you're ready, now that you know kind of the concept or the idea to solve this problem, let's see what it looks like in code. On the screen here, I have a helper function, a swap function. So we're going to define a swap function to do our swapping for us. And then we're going to do all of the logic for the rotation inside of this rotate function. So the first thing that we're going to do is we're going to create a couple variables. So we're going to create a low variable, and then we're going to create a high variable. So what's low going to be? Well, we're just going to initialize low to 0. And then high is just going to be equal to, this is basically just the dimensions of our matrix, right? So it's going to be equal to the matrix.length minus 1. So that's going to be the last index in our matrix. And then what do we want to do? Well, we want to keep rotating. We want to keep doing our rotation work while low is less than high. As soon as low is greater than or equal to high, well, then that means that we've kind of like terminated all the way to the middle, right? We're not in an outer ring anymore. We're in the middle, so there's no more rotating around the image that we actually need to do. So we'll say that while low is less than high, well, we want to keep doing our rotation. So what we'll do is we will add to low at every iteration, and we will subtract from high at every iteration. And so the other thing that we need to know is we need to know what is the distance between our low and high, right? Because as we're iterating through those rings, we need to know what is the width of this ring, like how far across the ring do I need to go? What are the dimensions of this ring? So we'll create a length variable to be the length or the dimensions of our ring, and that's just going to be high minus low. So that's going to give us the dimensions of our ring, which will be very helpful to us in actually iterating through this. So of course, now what we need to do is we need to actually do a loop around this ring. So we will set up a loop here for this. So we'll let I be 0. And while I is less than length, we will keep looping. Okay, so now we're going to loop around our ring. We're going to do a ring around the image here. And we need to do 3 total swaps, right, with that first index to move that, that number. So we'll do a swap, and we'll set up 3 of those swaps. And we want to swap the top left corner with each one of the corners at every iteration, right? So that's the 3 swaps we're doing. We're swapping here, and then we're finally swapping on the left side. So so of course we need to pass the matrix into all of these swaps. So we'll do that first, passing in the matrix. And then, so what is this top left corner? Well, that's going to be 0, right? So our low bound is the first index. So we're going to pass the index in to this swap function. So for that top right corner, right, that's going to be the first row on the last column. So that's going to be our low bound and our high bound for that column index. And then for actually passing, we need to also pass in the location of our top left, because that's what we're swapping with every single time. So that's going to be the low. And then we'll create a variable called index. So we actually want to, we can calculate this out of here. So we'll create a const index, and we'll set that equal to low plus the plus I. Okay, so what is low plus I? Well, our first index is going to be at the 0th row, right? And then as we iterate through, it's going to be 0 plus our plus I is going to be the swapping position. So that's low plus index, or low plus I is going to be equal to index. So we're going to pass that in to every call to our swap function. And then how is that top right corner going to move? Well, it's going to move down that right side, right? So we're going to be incrementing the row each time as we're iterating. So that's going to be, we want to increment the row, right? So that's low plus I. Okay, great. We're not changing the column, right? We're just changing the row. So what about the bottom right corner, right? What about that one? Well, we're starting at the bottom right corner, and we're kind of moving along the bottom, like back toward the beginning, right? So that's going to be a bottom right corner. So that's going to be our high bound and our high bound, right? So that's going to be like the last row and the last column. So that's high bound and high bound. And then of course we want to pass in low and index. Pass in low and index for our what we're swapping with. Okay, so so we want to not change the row, but we want to change the column. So we'll subtract I from the column as we're moving through. And then finally, what about that last? So that's the bottom left corner. Well, that's going to be high for the row, the last row, and then it's going to be low for the column, the first column. And then we actually want to move up, subtract from the row. We want to move back toward that 0, 0 position, right? So we'll subtract I from that. And then we'll, of course, pass in the location of our swapping index, which is going to be low and index that we calculated right here, which is just low plus I, because we're starting at 0, 0, and we're adding I to the column. Okay. So now we need to do the swapping part of this. So the swapping part, this is just a basic swap function. So we just need to define a temp, and we'll set that equal to the swapping index, which is going to be the last two variables we pass in. So it's going to be K and L. And then we want to set this location. We want to set this location K and L. We want to set it equal to the first two indices that we're passing in, which is going to be I and J. Okay, and then we want to set I and J, so the matrix at I and J. We want to set that equal to temp, the value that we stored. So this is basically it, right? We need to of course we need to return the matrix at the very end. Okay, so we'll return the matrix. Awesome. So that's basically it. That's all the logic. So what are we doing here? Well, we created this swapping function, which just swaps two indices in our matrix, in our 2D matrix. And then we created this rotate function. So we just established a low bound and a high bound, which is basically the dimensions of our 2D matrix, right? And we're going to decrement the size of that at each iteration till we get down to the middle, and we can't we don't want to rotate it anymore. Like once low is greater than or equal to high, well then we know that we've rotated everything, right? We've reached the center of the picture, the image, or whatever you want to call it. And then at each iteration, we want to iterate through the ring. We want to go all the way around the ring. And how are we going around the ring? Well, we have this length variable that we're calculating here, which is high minus low. That's just telling me what is the length of one side, right? And I'm iterating through each side as we go around, swapping, kind of having this motion happening, swapping the indices, and we're doing that using our swap function. And then we are shrinking the size of our ring at each iteration, and then returning the matrix at the very end. So let's see if we have any bugs. Okay, great. 72 milliseconds. Let's see if we can do a little bit better. I can't keep trying. Let's see. Let's give it one more try. Okay, awesome. 68%. LeetCode, I think they don't like me just bad mouthing them all the time about how they're purposely slowing down my runtime. So it looks like they fixed the problem. I don't know what the problem was. I don't know what they were doing, but they definitely were trying to make me look bad. But it seems like that's all over with now, because look, we just got 100% on one on one of our problems. But anyways, this algorithm, or this function, this problem, it can be really tricky, just kind of getting that logic right for that rotation. It's not terribly tough in concept, but definitely challenging in implementation, especially to do it in a clean, concise way. So if you were able to achieve that goal of actually implementing this function in under 40 minutes, congratulations to you. I didn't quite get there myself. It took me a little bit longer to clean it up and get this looking in a presentable way where I could actually show it to you guys. But anyway, I hope you enjoyed this video. I hope you learned something, and I hope to see you in the next one.